In this session, I'm going to talk to you about deployment service for CubeSat from ISS. First of all, I introduce of JAXA. The Japan Aerospace Exploration Agency, JAXA, was born through the merger of the three institutions, namely Institute of Space and Astronaut Science, ISS, the National Aerospace Laboratory of Japan, NARU, and the National Space Development Agency of Japan, NASA. It was designed as a core-performance agency to support the Japanese government's overall aerospace development and utilization. JAXA, therefore, can conduct integrated operation from basic research and development to utilization. I'm showing the representative project here. We have some mission, for example, today. I would like to explain about one of human space activity missions. It is a CubeSat development mission. International Space Station, we call ISS, is a huge manned construction located about 400 kilometers above the Earth. And it is a circle around the Earth at the speed of 90 minutes per orbit. The ISS project aims at improving science and technology to enhance life and industries on the ground. 15 countries are participating in the ISS project, including NASA, Russia, ESA, Canada, and Japan. Okay, Japanese module is here. Japan has conducted the human space facility, the Japanese experimental module, okay, GEM, KIBO, and trained astronauts who will operate the ISS and KIBO at JAXA. KIBO has a pressures module and exposed facility. So a variety of missions can be conducted both inside and outside KIBO. At the KIBO exposed facility, there are a lot of unique systems. It has airlocks that allow payload to be moved from inside to outside the KIBO. And small robotic arms, it called remote manipulator systems, GEM-RMS. So many missions can be operated at the KIBO exposed facility. One of them is a GEM small satellite orbit deployer. It's called JSOD. JAXA developed this unique system to deploy the satellite and inject orbit from the KIBO. This table shows a specification of JSOD. A satellite size is defined a unit, and 1 U is a cubic of 10 centimeter, 10 centimeter, 10 centimeter. The JSOD can be released up to a 6 U satellite. And 50 kilogram class satellite can also be released. Even though 1 U, 2 U, and 3 U size of satellite is limited in JCube program, the ISS is moving in the direction of the x-axis, and the satellite will be deployed 45 degrees backwards for the direction in which the ISS is moving. The maximum deployment velocity is 1.7 meter per sec. And speed changes depend on the mass of the satellite, okay? For the deployment mechanism of JSOD, there is a big spring inside the JSOD case, and then separation mechanism set on the outside of the case. As the satellite is loaded, the big spring is compressing, and the satellite are kept in the case by the door. This door, okay? When the separation mechanism receives the command for release from the ground, the separation mechanism moves, the door is opened. Finally, the satellite in the case are pushed by the spring and deployed. There are two types of cases that can carry a satellite the size of CubeSat. In the JSOD case, the satellite is a set of the case. They are set to the case on the ground, and the maximum size is 3 U in the slot. While in the JSOD-R, the satellite is loaded into the launch case. and transport to the ISS. Where is it stored in the Kibo module? In the Kibo module, the satellite will be transferred to the deployment case by astronauts. So the JSON-R can be used repeatedly, and can release max 6 satellites in the slot. In addition, although not shown here, there are a special case for the wide 6 size and 50 kilogram. Next, I explain how the developed satellite will be transported to space and deployed. First, the developed CubeSat is installed on JSON case, and then packed into a cargo transfer bag. Then they are transported to NASA and launched as pressurized cargo by rocket. Because of CTB bag, the vibration environment is lower than that of the rocket. So after the JSON case arrived on the ISS, astronaut mount the JSON case on the platform, okay? And then platform is carried out of the ISS through the airlock, okay? And then robot arm carried it to the deployment position. And the satellite will be now, okay, deployed. Yeah, okay. In this movie, so satellite deployed. Okay, I'm sorry. The next shows the operation command to move the robot arm and to deploy the satellite are sent from the ground. Flight control team and the engineering team are in the perfect condition and support deployment from the ground. The size of the satellite is small, but the mission is made possible by many support members. Next, I show the requirement of JSON and safety review in ISS. So requirement of JSON must be satisfied in order to deploy your satellite using JSON. So this requirement is Gen Payload Accommodation Handbook Vol 8. Okay, so you can download this document from this URL. I would like to applicant of JQ program to read this document. Okay. So next, I show the safety review in ISS. JAXA is responsible for guaranteeing the safety of the Japanese experiment module, the visiting vehicle, and other payloads. JAXA Safety Review Panel are chaired by the Director of Human Space Safety and Mission Assurance Office and the Safety Review Board. Will review human system, including experiment and payload. According to the system safety standard and the safety review process requirements, risks will be minimized as much as possible by managing hazard. Next, I show the procedure of safety review. Hazards that may loss of ISS and directly harm crews or indirectly harm crews by damaging safety related system should be identified early in the design process. In the case of CubeSat safety review, phase 1 and phase 2 are merged and held after critical design. In the safety review of phase 1 and 2, a user of satellite make report including understanding that the target system, hazard cause identification, risk assessment, elimination of hazard causes, and set control verification method. Okay, and the safety panel check this report and review it. After production and testing of satellite, safety review phase 3 is held. Verification of hazard control method and evaluation of residual risk and checked in this review. After this review are passed, a satellite can be handed over. Next, I introduce the achievement for JSON. The JSON operation started in 2012, and this year marks the 11th year. JAXA have conducted to provide development opportunities. So 72 satellites from 31 countries have been successfully deployed from the JSON. As you can look at the world map, we are releasing satellites from all over the world, okay? Regardless of region. Also, 8 teams of satellites were released by JCube program. And so far, and 2 satellites of 1 team has been successfully developed last month. Next, I introduce capacity building through JSOD. JAXA has provided us opportunities of satellite deployment to various countries as a gateway for sharing the values of ISS Kibo for the purpose of enhancing satellite development and operation technology. JAXA launched new comprehensive capacity building measures to provide the educational programs and sustainable satellite deployment opportunities, which finally contribute to the SDGs goal 4, 8, and 9. JQ program, okay, is introduced by after my presentation. KiboCube is programmed in collaboration with UNISEC. KiboCube program can provide one-size CubeSat deployment. You can search KiboCube using Google by and Yahoo, okay? Finally, I introduce KiboCube Academy briefly. JAXA and UNISEC launched the KiboCube Academy and posted a series of online lectures on the UNISEC website in order to enhance opportunities for the educational aspects of the satellite development. Its operation, the project management, and system engineering. JAXA also provides a technical consultation for a potential applicant of KiboCube by collaboration with UNISEC. You can find a webinar on webinar section of the following this website, okay? And now you can see 21 lectures which are used for development of the CubeSat. This year, 3 new lectures will be added in this lecture. We are hoping to see my institution apply for JQ program and explore their possibilities of the space utilization. JAXA is looking forward to support your challenge. Thank you for your kind attention. My presentation is finished. Thank you.
Fujita-san, thank you.